at the top of page 4, let's write linear, exponential, and quadratic relationships. Okay, can somebody tell me what we've learned in the last few days about linear relationships? What? Okay, it forms a line. What else do we know, Kayla? Yes, so it either goes up by the same number or it goes down by the same number, right? Okay, so let's make a table. Just on the left side here. So 2 columns, and let's do 5 rows. So we have our X and our Y column. Yep, just like the same size. You know, each row is a line. And let's say our X values are -1, 0, 1, and 2. Question? Oh, okay. -1, 0, 1, and 2. And let's have our Y values start at -1. And let's increase this linear function by 3. So if we increase it by 3, then we'll have 2. Then our next point will be 1 and 5. Our next point will be 2 and 8. Okay, so that's a linear function because the difference, and we're going to do this to the side, so this will be the difference, is the same. So -1 and 2 has the difference of 3. 2 and 5 has a difference of 3. 5 and 8 has a, right? So it's all the same number. So when that happens, we know we have a linear relationship. So, and we're not going to graph yet. We'll graph in just a minute, okay? Oh, yeah, if you want to write. So this is linear. Okay, let's make another table. Yep, same size. And let's have our X coordinates, we're going to have them start at 0, then 1, 2, and 3. And for the Y coordinates, we're going to have 0, 1, 4, and 9. Now, let's do the same thing that we did over here. So let's find the difference between Y values. So what is the difference from 0 to 1? +1, right? From 1 to 4? 3. From 4 to 9 is 5. Notice, it's not the same number, right, like our linear relationship was. But what if we do a second difference? So what if we do the difference of 1 and 3? What's 3 and 5? 2. So let's make a little note here under this table. When the second difference is the same number then it's quadratic. Yep. So with the length and width of our rectangles yesterday, if we would have done the second difference of the lengths and widths, it would all be the same number. Okay? That's what makes it quadratic. Or that's how you can tell from a table. Now, what's the last one we got to talk? So this is quadratic. If you want to write that on the side. So the last table, let's do the same size again, 2 by 5. Okay, let's do the x values 1 through 4. Bless you. Let's have the y values be 1, 4, 9, 16. Wait, I don't think I did that right. Oh, I didn't do that right. I messed up on the last two. I'm sorry. I was squaring instead of doing 2 to that power. Sorry. 8, 16. There we go. That's what I meant to do. Oh, wait. 2 to the first is 2. Oh my gosh. I'm going to get this right. I promise. Okay, this is a 2. So 2, 4, 8, 16. Okay, so right away we can tell, let's see, the difference of 2 and 4 is 2. What's the difference of 4 and 8? 4. Difference of 8 and 16? 8. And if we did the second difference, would it be the same number? This would be 2 and this would be 4. So we know it's not linear, we know it's not quadratic, so that's when you should probably see, okay, does it have the same ratio? So does this y value, 16 divided by 8 is 2. Then we do the next one, so then we go 8 divided by 4 is 2. Then we do the next one, 4 divided by 2 is 2. So if it has, let me scroll down a little bit. So if it has the same ratio, then that means it's exponential. And remember, to get the ratio is when you have to either divide or you multiply, depending which direction you're going, right? Because if I went from 2 to 4, that's timesing by 2, right? 4 to 8, yeah. Okay, so that is going to be exponential. Okay, so now on our Post-it note. So do you guys still have room? Is it on the side of your page still? Okay. Where's my copy button? There we go. Copy. And paste. Okay. So right here on the side, let's try to graph all 3 of them. So however you can fit them, hopefully they'll fit all 3. If you need another Post-it, let me know. But let's just try to fit all 3. So the linear, we need to go on the x-axis just -1 to 2. Let's number. Okay, hold on. 1, 2, 3, 4, 5, 6. Okay, so on the x-axis, we need to go from -1 to 2 for the linear, and then we need to go on the y-axis from -1 to 8. So something like that. Okay, and you can number by 2s on the y-axis if you want, or each one is 1. It's totally up to you. I think I have enough room to do 1s. No, I don't. Anyhow. And then I have -1, 1, 2. So let's plot these points. So -1, -1, 0, 2, 1, 5, and 2, 8. And then go ahead and draw your straight line. could even, if you wanted, I guess, is just do them on the same coordinate plane, all three of them. If you'd like, but it's... Okay, so the quadratic. Let's do the quadratic now. So we need to go from 0 to 3 on the x-axis, and then from 0 to 9 on the y. So we only have one side of the parabola, but it will be symmetrical on the other side, just so you know, okay? So if you want to draw the other half, so it will look something like that. You guys see it okay? Remember the exponential? This one will actually approach the x-axis but never actually touch across. So it will look like this. All right? So linear has the same difference. Quadratics have what? The same second difference, and exponentials have the same ratio. Good job. Any questions on this right now? Okay, I'm going to send you a question on your calculator.